Hey everybody, Jason here. I hope you're all doing ridiculously good. Today, I'm going to be working on a Dremel 3D45 mainboard. This printer is said to have had one of the stepper motor drivers fail. It's said that it just quit working on one axis. So we're going to have a bit of a closer look at this today. This customer, they have already narrowed down, it's already open, which driver it is, and it is said to have a hole in it. And they were nice enough to also send along the replacement chip. And I believe we probably have, yes, we have 2 replacement chips. So here are the replacement chips. I sure hope we don't need 2 of them, and I don't actually destroy one of them. That'll be embarrassing now, wouldn't it? So if we look very closely, we can see that we actually do have 4 of those chips on the board. And I think if we get in and we look at this one right here, there is in fact a hole right there in the top of it. Now, this customer explained that his intern Anna had been working on this and actually has already figured out exactly what is wrong with it. So there's not going to be a whole lot of troubleshooting here. So having a much closer look at this thing, we can see that there absolutely, positively, is a hole. Look at that. Is that freaking crazy? This thing has a freaking hole. It's not like a volcano, or it literally has a hole that you can look down inside, for crying out loud. Well, let's not waste any time here. I'm just going to replace the chip. This is not a board that I'm able... That looks like a standard computer power supply plug. This is not a board that I have all the peripherals and everything to plug in and to be able to test it. But boy, oh boy, is it tempting to connect a ATX power supply to this thing. We're not going to do that today. Holy smokes, we've got USB, LAN. Anyways, I'm not going to waste a whole bunch of time troubleshooting or even taking any measurements on this. What I'm going to do is just go ahead and get set up and replace this chip and send this thing back to the guy. It'll most likely be fine. All right, because I am profusely serious about burning this guy's connectors, I'm going to use an old trick that was actually used by the Egyptians. As you can see, I've just sort of taken and like wadded up Kapton tape all over the top of things here that I don't want to get burnt. I sort of missed that connector, but that'll be okay, right? Now, here is where the ancient trick comes into play. We're going to use aluminum foil here with a hole cut in it and just kind of push that around everything. You know, I'm going to need to be real careful. On the bottom of this board, there's a speaker. We're going to try to make sure we don't damage that, but I also don't want to go through the trouble of moving it because it's on like the opposite side. So this will help me to not burn his connectors, but it also helps me to be, I don't know, a little less careful. There's a certain level of comfort in knowing I can just lay my hands here or there, or if I bump here or there, that I've got the rest of this board shielded. This board is out of like a $2,000 3D printer, and I want to just make absolutely sure that I only touch what it is that I'm here to touch. All right, one last little piece of tape on it here. I do have some concerns about those nearby capacitors. I'm going to be trying very hard not to overheat those because I believe they can swell up and pop. All right, I've got this thing positioned under the microscope nicely. I've got it zoomed all the way out, and as you can see, this thing just barely fits. So I'm going to go ahead and start warming this board up. I've got my hot air set on 240 degrees C with an airflow of 65. And I'm going to apply just a baby amount of flux to the perimeter of this. Now again, because I am unfamiliar with this, much like the telescope board repair video that I posted just before this one, I'm going to lower the melting point of this using some low melt. So as this board warms up, I'm prepping my iron by dipping it in some low melt alloy, and I'm just going to begin flooding the pins with this. You know what? I almost forgot to mark pin 1, but if you look here, we've got this big old circle down at the bottom right. I'm going to say that's just as good as being marked, right? So I'm just going to take and flood this with some low melt. Boy, that board has some mass to it. Holy smokes. This might actually be a challenge, being one of the largest chips I've ever replaced. Okay, we're going to need quite a bit more flux than that now, aren't we? So let's get a little bit more flux on it. Oh yeah, that's what we were missing, flux. Okay. Should be a pretty straightforward repair. That is, as long as whatever caused that hole to get there in the first place gets taken care of. And the guy that sent this in is concerned that it was like wiring or one of the motors itself that caused this. So if you are watching this channel and you know a lot more about this than I do, feel free to let me know. Do you think that this thing is going to fail again after I replace this chip? Is he going to get it back and be let down? Oh, this is terrible. Let's switch to a bigger iron. Here we go. Oh yeah, much better. Hey, don't laugh, okay? I work on cell phone motherboards all the time. This is new for me. Okay, I'm just going to make sure I've got all 4 sides sufficiently flooded with low melt. And then I'll bump up the temperature on my hot air here and see if I can get this to float free. I'd not be surprised to see it starting to happen just from my iron touching it. And also, I don't know if this chip has a ground pad in the middle. We might have a big old hunkin' heavy ground pad in the center to deal with that I can't flood with low melt. Okay. Should be getting close to up to temp. I wonder if I can do this without raising my hot air. Doubtful. All right, I'm starting to see meltage around the edges. Okay, I'm going to raise my hot air up to 340 degrees C, and I'm going to go down to an airflow of 20. And the low airflow is because of my heat shielding raising up. I don't want this blasting hot air to get under it and burn a connector that's close by. I'm just seeing if I can get this thing to let go. I'm not sure. I think there's probably going to be a ground pad like right in the center of it, which is going to be a little bit annoying to deal with. I think that's what we're looking at. So now what I'm doing is looking under my shielding, and I'm looking to see when the air blows under it, what else it's going to cook and whether or not it's going to be okay. I think it's going to be okay. So I'm going to adjust my angle a little bit here. I'm going to go up 340 degrees C, airflow of 40. All right, let's watch for things to melt. I'm going to raise the hot air. I'm at 430 degrees C with an airflow of 40. Yeah, it looks like we're melted all around the sides, but it's not coming up in the middle. So I'm going to switch to an iPhone CPU tool here. And slide it right under there like that. I'm trying to get this to let go. Come on, baby. Any moment. There we go. Ah, gosh, why do I always do that on camera? Oh, I'm so embarrassed. All right, I dropped it on this board. Oh, God. All right, nothing to see here, folks. Everything going on here today is just completely normal. All right, so while this board is still hot, I'm going to take me some wick and begin cleaning off this nastiness. Let me know in the comments below if you have ever used a micro chip flipping tool to remove quad flat packs with big ground pads in the middle.
Come on, solder. Gosh, I'm like a bumbling idiot on these larger circuit boards. Like,
All right, just about got the old crap cleaned off here.
there we are.
Now, as always, I'm going to clean this up with a standard issue Q-tip and alcohol. All right, now I'm not too terribly comfortable with never having touched the center pad with another alloy other than the crappy lead-free crap that came on here. So I'm going to go ahead and just kind of, you know, put some leaded on there. There we go. That ought to give us a bit of a ground in the center that we can join to. Now also, since I did go ahead and put leaded in the center, I'm going to go ahead and fluff up these outer pads with some leaded, and that way I might be able to just float this thing right on down there, but because this chip is going to need that center grounding, I wouldn't be comfortable trying to send this out of here without that center ground on there. So I'm going to be trying to take great care to be sure that center ground floats into place. And why not go ahead and have these float into place at the same time, right? I know, I'll still have to solder it by hand. Now I'm going to be extra compulsive here and clean up this tiny little bit of burnt flux in the middle and put some fresh flux on here. I'll be able to go around and hand solder the outer pins, but this center ground that I believe is going to be pretty important for cooling of this chip, I'm not going to be able to solder that. So it's really important just to have that solder itself. Now I'm rotating it a bit here just for hot air angle. I want to get a better angle on my hot air. Less air on those capacitors that are right next to it, for crying out loud. All right, let's get some flux on here, shall we? Let's take our brand spanking new quad flat pack and drop it right in there like that. Let's try to get it lined up. Now the goal here is, first of all, not to blow it off the table, and secondly, to get it to float itself into place. I'm going to start warming this up. Now it's got to get pretty stinking hot for that center pad to do its thing, but it will. It'll do its thing. Okay, here we go. Trying to raise the temperature of the board up under it so I don't cook the chip before it ever goes down. Okay, here we go. Now once I see it floated all the way around like that, I can be pretty stinking well confident that the solder that's under the chip has also floated as well. Now, I know there's no way for me to sufficiently judge that gap, but what are you going to do? So while the board is still hot, I'm going to go around here and solder these by hand. And I'm going to try to get away with using my micro pencil because I just have so much more control out of this thing. Oof. And make sure all these solder joints are nice and pretty. Oh boy. Well, that sure is embarrassing. Now, let's see if I can pull that out of there with an iron. I just set and bridged two of those pins like a dillweed. Nope, that's not coming out with an iron. That's a nice big old fat bridge. So for this, I'm just going to take me a piece of wick. Just take a piece of solder wick. Oh, the angles and everything here are just terrible. All right, here we go. All right, solder bridge, delete. Oh my goodness. I'm about to have 385 people tell me about how crooked this chip is. Like, these people won't realize that going to bed with this, knowing this chip was crooked, is ruining my life already. But no, go ahead. Tell me about it in the comments below that I am off by a couple of microns. All right, let's see, that's two sides. We just have two sides left now, don't we? Ah, the board is so hot. The board is big and it's hot, and I can't lay my hands on it, so that makes this challenging. All right, one more side left. Goes right there. Glad to say it doesn't look like we have any ground on that side. So I can knock it off with the preheating and quit burning my hands. Here we go, let's do this one last side. Oops. I don't like seeing how fast the solder travels up those legs. I feel like I could actually do damage inside the chip, so I'm trying to stop before that happens, but that's not exactly working out every time because it does it fast. Oh, this is a terrible angle, and I've just caused another bridge. So let's just get us some wick in here. Come on, baby, suck it up. There it goes. All right, I think that is looking pretty good, which means now it's just time to clean it up with some alcohol. So we're just going to clean this up and make it look nice and pretty. And I've just about got this thing all the way cleaned up. And then I'll have a closer look at it, make sure there in fact are no solder bridges. No solder bridges. Everybody's probably looking at this one same spot that I'm looking at. I did have a significant bridge down in here, but I believe what we are all seeing is just these legs being slightly off-centered. And if we want to get really critical, like they're still completely on the pad, they're just not in the center of the pad. All right, so there we have it. This is a nicely replaced stepper motor driver for a Dremel printer. I'm going to say that the soldering here should be completely acceptable. And this should be a happy customer. I want to make sure I absolutely, positively did not burn any of the connectors. And I also like to make absolute positivity that I'm not sending this thing out with any funky, big old nasty sticky spots on the board. I like to send them out of here just about as clean as I can possibly get them. So this board is going to be good to go. We have a nicely replaced stepper motor driver that no longer has a hole in it. And I am very much looking forward to telling this guy his board is ready and then also finding out if the repair works. So if you have something that you would like to repair and it's worth repairing, or at least it's worth repairing to you, feel free to get on our website and submit a request and see if it's something we can take in, and maybe we can help you out. So that is going to be the end of this video. If you like my video, please give me a big thumbs up. If you like this type of thing, then subscribe, and I'll see you in the next one. Have a good day, everybody. Thanks for watching.